G'day Bifrosters. Well, here it is. The building generator, giving you the run through. So here's the plan for this. This has been pretty popular since I teased it. My bad, shouldn't have teased it, but it's a big job. And it's a very simple building generator and it only generates very simple buildings. We stop the render, take a look, let's hide our ground, delete that sphere that I don't need anymore. So it's quite a simple building. It's basically made out of cubes. A whole bunch of cubes all joined together. Not really cubes, obviously, but there you go. So you've got each floor in there. So a couple of things before I just give you the quick run through of how the node works and how I got this to work. First thing is it's very much a work in progress. There will be other things done to it, and I'm going to be doing more to it and trying to get a better result. It's a almost direct copy of Simon Houdini's house generator in Houdini, except I'm doing it in Bifrost, and I'm doing it the Bifrost way. The biggest thing that is going to change is the way that instances work. So I'm still working on that at the moment, but at the moment I've just got 6 instances, 6 geometry coming in a very specific order that I refer to later on. I'll explain that when we get there. But what I'm trying to get working is you put in all your wall shapes, you put in your bottom floor shape, you put in your top floor shape, and shapes, and then you'll have more controls to control them there. So that's just a bit of a caveat before we get started. I'm going to go ahead and keep going on about it. So this is the tutorial I based it off. It's the house generator revisited. I wasn't trying to stick as close to possible to this tutorial, but this just makes sense. So I did it the Bifrost way and with Bifrost assets. And yeah, let's get into it and show you how I did this. And hopefully we can work on it together and improve it. Here is Create Office Block. The reason it's called Create Office Block and not Create Building or Building Generator is because it's really only good at creating office blocks. Big, chunky, square office blocks. It's quite procedural. I can change the number of floors quite quickly and easily, and that's all doing its thing happily. And then 5 floors, more of an apartment looking thing. I mean, it does do quite good Hong Kong apartment buildings. If you do something like 52 floors, there you go. So you've got 2 controls here, footprint X and Y. This is the maximum size the building can be, the footprint in the world. So I can just change that down to 5. You see that the shape changes a bit, still 52 floors high, but it's a very skinny building now. And you've got footprint Z as well, so if I just make that 30, you should have quite a long and skinny building. Obviously that's not 30 from this edge to this edge, and we'll get into that and why that is in a minute. So we'll just go back to 15 by 15 to start with. Then you've got 2 frequencies. One is the frequency of the general shape of the building. So you can think of that as being the frequency of this thing. And we bring the frequency out and it gets noisier and noisier and noisier, as per. Then you have more of a fine-tuning frequency which tunes the edges of this building. And if I bring that out, you see how that gets a lot noisier, a lot faster. So that's more of a fine control. This is a very quick overview. I will be going into the node. Don't sweat too much. We're good. This is not in order just yet, so the next thing we do is the seed for the doors. You can see there's a door there. Change the seed. You get doors appearing and disappearing all over the ground floor. And notice that they're only on the ground floor. This is the chance of having a window. At the moment, it's a 100% chance, but as I drop that down, you get less and less windows and more blank walls. You can see there. It is definitely random. There's a seed for it, so you can change the look. Then you have menu shape, which it just allows you to build a big square building. So if I switch that on, that building is now 12 by 8. And just to prove it, let's make it 12 by 4, so it's a bit skinnier. So if you needed to do square blocks, you can, just by using the menu shape. And finally, with the menu shape off, because the building seed won't do anything, is the actual building seed. So you can now scroll through this seed and get different shaped buildings, to please your aesthetic sensibilities. Those are the exposed control. All good, right? So let's reset some things. 15, 15, 52 is probably a bit big. Let's just go down to 10 floors. We'll center up on that. All good. Frequencies are fine, the seat is fine, the window is fine, the doors are fine. Go to 4 doors. Window seat is fine, that's all good. So let's jump in and see how we do this. So that was the quick overview of the node. That's how to use the node right now. And of course, like, because this is Bifrost, I can select this guy in Maya. I can change the scale quite happily, no problem. I can also rotate it, but I'm rotating the entire graph. Let's have a look at how this works. Let's jump in here. Immediately you can see it's fairly complicated. We'll just put our outliner and our Arnold renderer away for now. So I have, and I'll supply this file for you guys to have a look at, play with and pull apart. I have pretty much broken it up into the important sections, and each one of these has a display so you can see what's going on. So let's start with these two. Now, that's not a Bifrost node. Quick Grid. Nobody knows what Quick Grid is except me because I built it. We'll jump out of here. And we'll go turn off the building. Let's turn on our grid as well so we can take a look. What the hell is a Quick Grid, Val? Well, that builds a grid. And of course, if I want to see the grid, I'll have to turn that on. So it makes a grid. In this case, if you take a look, it makes an X, Y, Z grid. We have two things plugged into the X and the Z, which are footprint X and footprint Z, and that is quite simply the footprint. So these are both set to 15 at the moment, I think. What Quick Grid does for me is it makes a grid that is 15 wide by 1 high by 15 deep in a step of 1. This is important. Everything to make this building generator work relies on it being 1 by 1 grid, 1 by 1 instances. It makes the math work, it makes it easier. Everybody's happy, right? So what Quick Grid does is it makes a grid. It makes a grid with this many in the X, this many in the Y, this many in the Z. The distance between the points are 1. So the step. It has an offset. I can drop that grid down. I can raise that grid up. I don't want to do either of those. And obviously I can change its color. So make it that little sort of nice blue that everyone likes. I can center the grid. And if I want to know what my first point is, I turn on show 0. It tells me that is point 0. Just a little diagnostic thing there. So in the Houdini tutorial, generated the shapes for the building with an L system, which I tried. I tried using Maxine's L system, and through no fault of Maxine's L system, and through every single fault of my stupid brain, I couldn't get it to work. So I came up with my own way to do it, and this is it. What I'm doing is I'm making a grid, getting the bounds of that grid as an object, and then I'm using, if you take a look here, I'm using the position from the grid as feature points on this array. Now center and distance. Before we go any further, I've made a lot of tools for this, and I'm not going to go through every single tool I've made, but I'm going to supply the file. I'm going to probably do videos on each tool later on, but for now I'll just give you a quick run through of what they do, and we're all good. What this one does is it takes in a plane and a set of points inside here, gets the centroid of the plane, and gets the closest positions, closest number of positions to that plane. This is what return n positions is. Returns the closest in order, then gets the array size of that, generates a random value on it, so basically it's picking this array, which is the closest in order, it's re-randomizing it. It's then getting the distance from the center, so it's subtracting the centroid, and it's subtracting that value from it, and then giving you the distances, and that's what we're using. The point display here doesn't do terribly much, doesn't even show you anything. Carrying on, what I'm also doing is I'm making a noisy threshold. What that means is that I'm using simplex noise here and another simplex noise here to generate some numbers. And I am generating as many numbers as in the grid. So in this case, it's 15 by 15, which is 225, I think. So number of grid positions, all right, and it's just creating a noise value for each of those positions using the frequency, which is what we looked at before. So here's the first frequency, and then the second frequency is here. This is the second noise, this is the first noise. It's then remapping that to 0 to 1, so it's changing the range from -1, 1 to 0 to 1, which is cool. And then I'm feeding in two values, minimum, maximum. And I'm remapping the noise to that value, those values, and outputting it. And what I'm doing, using these noisy values as a threshold for these points. And because these points are in the center, and this is noisy, what I'm basically doing is removing everything outside of that noisy threshold. So it's finding everything that has 0 value in the array and removing those indices from our main grid array. So this here is our main grid array. And then I'm outputting that. The reason the if condition exists is that basically if I want to just make a square object, not a noisy round, I will feed another grid in that is just a square object. So this will give us a square output, this will give us a noisy output. Let's have a look at those outputs. So if I turn this on, you can see that I have a noisy output. I have a blob, which is taking up some of these grid points. And if I was to turn on manual shape, you can see that it's made another grid there instead. So that's what that does. That gets us the footprint of the building, and all of the settings work. So if I just go to main building seed and I change this, you can see I'm getting different shapes. If I go to my secondary frequency, my edge frequency, I can do this kind of thing and get different noises through, different shaped buildings. It's great. Everything's working as expected. I can change my footprint here, and you see my grid change size. Floors don't come until later. And yeah, that's about it for now. So what this is doing is it's generating a shape of points within a grid of points. I'll turn this one off now. And now we just have what's going to become the floor plan. The floor plan has become the ground floor of our building. And that's the next thing we do. So here's our footprint points. They go out to an elbow, and then they get constructed to points later, which we'll get back to. But for now, what we're going to use them for is instancing a 1x1 plane on each point. So this node, which I've made, because you can see it's got my funky little logo on it, this node is simply a very, very quick and dirty instance. It sets the point orientation, sets the point normal, and then bakes instance geometry. So here's the instances, here's the points coming in, here's the geometry coming in. It's really, I don't know why I did it. I should just use the instances, but I think I was just trying to do Houdini but better at the time, which you'll have to forgive me for. But that all being said, I'm taking a 1x1 plane and I am instancing it on these points. And there you go. Let's just get a little bit more of an interesting building. Maybe. So the other nice thing is that the buildings don't have to be connected. It's kind of nice if they are, but they don't have to be. So there's an interesting shape. So this is quite an important step, because what this is, you can see this goes off over here, it goes off over here. This becomes the floor. So this is the ground floor, and it's also going to be every single floor moving on up the building. Yeah. You can change, well, I'll show you how we can change height between floors, we can do all kinds of stuff. Like I said, I haven't completely set this up. This is very much a first look and a work in progress. But that being said, we now have a floor. We can get rid of our point display for now. We'll come back to that. So we take our points, and this disappears off into the edge, which I'm not going to tell you about yet. You've got a nice terminal there. It also goes into this little box that says get edges, and what I'm doing here is I'm quite literally getting the edge of every 1x1 plane. Alright, I can show you that. So if I drop down the terminal, this. And here is a very cool node, collect boundary edges. This is going to try and find the boundary edges of each object. I originally thought it would find me in a continuous edge here, but as you can see, and as I found out, it doesn't. It's quite difficult to see because I've got that made really quite small. Let's jump in here. So it's maybe even thicker than that. So the yellow lines is what we're looking at. That is the edge of every single one-by-one plane that we've copied to those points. Someone is probably going to watch this and tell me how to fix it, but in the meantime, this is the way I found to work it out. So, this is cool. Now I have every edge of every instance that I've put on every single. Go back out to here, put onto every single point. You can see it's nicely centered, it's all set up that way. We'll get onto the rules around instances later, but for now, just bear with me. So this is a really good start. Now, like I said, this is the bit that was done in the Houdini tutorial as an L tree, but I'm doing it like this because I couldn't work out L trees because I'm a bit thick, or at least I'm a bit tired. So here's what I'm doing here. I'm getting the point position and I'm getting the structure of the strands. I'm putting the strand count out, so I'm looping through each strand in here, and I'm getting the strand offset array. And inside the offset array, I'm accessing the offset array and slicing it, and then making a new strand. And what this is giving me is it's turning one strand object here with all of its settings. I'm turning that into an array of strands. So every single one of these is an array coming out of here. And that's all I needed to do at this point. I needed to get all of the edges. And then what I'm doing is I'm going to remove the interior strands. So I'm going to take every single strand out of here that isn't an edge strand, isn't an outside edge. And that's what I was hoping collect boundary edges would do for me. And if I knew how to join up meshes, maybe I could have done that. But this, I don't. This is how I worked it out. So what I'm doing is I'm looping through each of those strands. I'm getting the point position, so there's 2 points, the beginning and the end of the strand, the first and the last in the array. I'm getting the distance between them, subtracting the first from the last, getting half of that distance and adding it back onto the first. And what that gives me is the center points of each array. But because this is an array, I'm getting a nested array out. So I'm making an array from an array, which gives me an array of arrays. I need to flatten that, which I've done here. And the result of that is this. And you can see the green points. I'm just going to turn off my geometry for the moment. What the green points are doing are they're giving me the center of each strand. And then we come back to the red points, the big red points, the big center points. That's what these are. So these are the footprint points. And you can see they go up into here, and they go off into the void somewhere to be looked at later. Again, quite important. Also, I have an elbow. I like elbows. They're a thing. So now what I'm doing is I'm getting points and radius. And if you want to take a look up here, like I have to every time I use the damn thing, returns the locations of the points on the input geometry that are within the specified radius of the input positions. What I'm doing here is I'm using the center points inside of the points in radius of 1. First green point comes in, like this guy, and it says, all right, within a radius of 1, find every single red point for me. And it does that, puts it out as the indices of that point, and then I'm looping through these indices. And what I'm doing here is I am looking for the number of indices in each one of these outputs. So this point has one neighbor, one red neighbor. This green point here has one red neighbor within a radius of 1, which is roughly, well, it's exactly that. This one has 2. It is that one and that one. So radius of 1 is here, so you draw a circle there. and this has 2. And this is what's going to tell me what's an interior point and what's an exterior point, because this is what I want to get, is the exterior point. Those are the points we're going to instance on. I also need the exterior strand. So that's what this does. It's just called for each 5. It's probably should be called find num neighbors. Would probably be a better description, but like I said, I'm still building this. We're building it together. It's a journey. It's exciting. It's cool. What I'm saying here is find me everything that has 2 neighbors, right? To go through all of the green points and find me every single one that has 2 red neighbors, and then give me the index of that. So it's going to go through every single one of these green points and find all of them that have this many, in our case 2, neighbors. And it's going to give me those. Oh, and that being said, when it doesn't find one, so if this is not equal to 2, it's not equal to 2, just give me -1. So find me everything with this many neighbors. Anything that doesn't have this many neighbors, call it -1, and we're happy. So this output here, if we look at it, it's not going to show us anything because we haven't turned anything on to draw from it just yet, which we can do here. Won't see any difference right now, but if I jump back in, you can see that the minimum value is -1. The maximum value is 175. This is telling me the indices by giving me the current index of the loop. It's telling me the indices of these. And -1 is the ones that I want. Well, it's not the indices, it's where it is in this loop. But it's giving me an array as it comes out. You see it makes an array here. All of that being said, what I'm doing here is I'm going to find everything in that array that is -1. Right? So this is, remember that this is finding everything with 2 neighbors. And anything that doesn't have 2 neighbors is going to be a -1 value. I'm finding all of the -1s and then I'm inverting that. So I'm basically find me everything that doesn't have 2 neighbors. So find me every green point that doesn't have 2 neighbors. And every green point that doesn't have 2 neighbors is an outside point on the mesh, on my footprint here. So you can look at it and go, okay, so let's pick that one. That one has 2 neighbors. Let's pick this one. This one only has 1 neighbor within a radius of 1. So that's an outside point, even though it's inside the mesh. Same with this guy. Within a radius of 1, so here, it only has 1 red neighbor. That's how I'm finding what's on the inside and what's on the outside. And if I come back here, that's fine, that's my yellow lines. If I turn this off now, and let's turn our yellow line, make our yellow lines a little bit smaller. See the blue dots? The blue dots are every single point that doesn't have 2 neighbors. And every single green point that doesn't have 2 red neighbors. Basically, we just turn this off and you'll be able to see them a little better. Maybe changing the color there might be a better idea. Let's just get something a little higher contrast. So you can see that every point here is an outside point, and it's done by checking the number of neighbors. It's a way to do it. And coincidentally, what this gives us are the indices to remove from our interior points, our strand centers, which is that array, the green one. So it gives us those ones. And it also gives us the indices to remove from our strand array. And what that means is that I have, let's just turn off real quick. We'll turn off that. And we'll turn this back on. And now I actually have the outline of the building that I can work with as well. So if I wanted to take this later on and make rooms in there, I could do that. It's something that I'm going to work on later, but it's a really good idea. Don't need that right now. It can go away. Now we're getting closer. At this point, we could put walls on this. So these are the points. We could instance walls on these right now, and it would not work. Well, it would work, but every single wall would be pointed the same way. What we need to do now is get the rotation of those points so the walls are sitting in the right orientation. Okay, we're going to go and do some stuff up here in a minute, but that's slightly separate. We'll come back down here. And what we're going to do is we're going to construct the tangents. Okay. And we're going to do that. Let's just take a look at this. We've got this set up. What we have to do is construct these directions. These directions represent the orientation of each point. The way we do that is another get point and radius from the footprint point object, just like up here. But this time we're testing every single outside point. And we're looking for radius 1, same as before. And then we're just flattening that array. So this is giving us everything in here that has radius of 1. Remember this guy? That has radius of 1. Every point within a radius of 1 from, on this geometry, from these points, which are the blue points that we have here. Turn off these arrows for a second so we don't get too confused. So we are looking for these points. And there's a footprint, because I didn't press T properly, and you probably have all been watching this video right up until now going, you didn't press T. So we're doing the same thing as we did before, but instead of doing it to the center point of every single one, we're just doing it to these outside ones. And then what we're doing is we're getting those points from this array, which is our footprint points, which I spelt right over here. We're bringing them in. And so we're getting all of the points within radius 1 of these, which are just going to be the red points. And we're subtracting from that this one. And what this is our outside points. So what we're doing is we're getting a vector from there to there. There to there, there to there, there to there, there to there. So we're getting a vector from the outside point to the center of whatever cube, grid, whatever grid, cell, sounds good. We're getting a vector from here into the center of whatever cell is closest to it. What that gives us is this. We have a vector from every single point to the closest neighbor, or the closest center of each cell, which is cool. Not quite going to work though, so what we kind of need to do is we need to reverse that, like so. So everything here, this is just display, that's nothing important, that's just so we can show what's going on. This is where it gets important. But right now what we have done is we've generated some tangents. So the normal and the tangent and the binormal of the strand, which all gets calculated up here, and we'll talk about that in a minute. We're using that to essentially make the orientation. To do that we need to calculate these tangents. So pointing away from the center of the nearest cell for every point. We've calculated those, we run it through a normal and tangent orientation. And of course to do that we need a normal to go with our tangent to make our orientation. Where the normal comes from is the update strands basis rebel pack node, which takes our array of strands, which is just the edges, just these guys, which are in the same order as these points. Remember how we found we found everything without two neighbors to get our outsides. That works for this strand array as well. And then we updated the basis on the strands, and what that does is it calculates from start to end the tangent, the normal, and the binormal of these. I took the normals, I flattened the array, and I plugged them both into normal and tangent orientation. That gives me a quaternion, which I can then use quaternion to axis angle, and that is going to give me axis and radians. I'll be able to rotate the point, and this is going to give me the point orientation. And now, with that set up, all of the looping, all of the instancing we can do will work. And I will show you that they work, because if I come and turn this back on, like this, we'll jump back in here. We'll just use one floor. So here's one floor. Actually, let's use two because there's things. So here's two floors. And if I go down here and I unplug this so we don't quite have what we need. You see what happens. Our walls completely lose the plot. Basically, they revert back to however they were built. What this is doing is giving me the angle for each point that the wall should be rotated, which is great. We're there, we're done, we're generating a building. Right now, all we've got is one floor. So, we now need to come up here. We're going to come back to this guy, I promise. We're going to come up here, we're going to make a loop. And what that loop's going to we're going to be able to do is it's going to take these points and it's going to loop them going up. Boom, 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 boom. So the first part of that is it takes the number of floors, which is this input here. Now, if you have a building with 0 floors, it's not really going to have a building. So what I've got here is I've just got a little check. And it goes in and says, hey, if number of floors is less than or equal to 0, right? If it is, just make it 1, because that's dumb. You can't have a 0 floor building. We'll just make it 1. So we've got 1-story building. Which, you know, is giving us our ground floor instances and our top floor instances, but it's doing it. But if it's greater than 0, if it's not less than or equal to 0, then just plug in the number of floors. All good. So let's go back up to 2. There we go. Then it adds 1 to it. It adds 1 to it so that basically we can just add this roof on top. And then it does a loop. It does a point floor loop. Well, not a point floor loop. It basically loops through however many floors you want, which is the iterations. Right? It takes the out points. Okay, sorry. That's not the loop. This is the loop, but you get the max iterations is the number of floors. It's going to run through this loop however many times you've told it to. It's going to take the current index, convert it to a float, and stick it in the y value. And loops run on integers. This is going to be the first time through, it's going to be 0. Second time through, it's going to be 1, etc., 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 etc. So what this is essentially doing is it's adding the whatever number of times through the loop you've been to the y position of these points. So we're essentially making duplicates of those points all the way up the chain. And they've got all of their orientations on them. They've got everything we've already worked out. It's all working already. That's great. Then it's setting a property that I'm going to use later when I'm sorting out my instances called point floor number and outputting it. Then it's merging, because that's an array right now, it's merging all of that geometry into a single object. And it's going out to be instance. So this is the instance node. Here are the points. This is the walls instance node. This is the instance array coming in. And what this does is it controls the ID overrides. So what really, really quickly going through here, because this one's where it gets complicated and what I'm trying to change. So I'm just going to show you really quickly what I did. So the geometry coming in, that's your instance points. All right, so that's these guys. Right now, it says it's a geo, it's an amino object, but it is only the points. It's the points to be instanced on. Nothing has happened to these guys until they hit this. So what I'm doing here is I'm taking these points and really, really super importantly, I am taking the number of floors, I'm taking all of the options that I want, so the number of doors, the windows, the door seed, and that kind of thing. And what I'm going to do is I'm going to generate some ID overrides, so instance IDs for this guy, for the points. And the way an instancer works is it takes these points and instances this array on it. This array, this instance array, is essentially this. 0, 1, 2, 3, 4, 5. 6 things from 0 to 5. Really important, that order, because we take advantage of the order that we make the array in to get this to work. So, let me show you real quickly. Inside the ID overrides, the very first thing we do is we get our point count and we make a new array of our point count. So the number of points The number of points in our instance object is going to be the number of things we are instancing. Okay, with me so far? It's coming out of the loop. Remember, it's merged, so this is however many points are in one floor multiplied by the number of floors at this point. Then we get the point floor number that we used before. We're going to use this. We use this several times, as you can see. First thing I do is I get the array indices for that, and get an array size as well. Then I make a random array from that size, and I check to see if that array is greater than or less than the window chance. Well, it's greater than, basically. So is this random, is the value in this random array greater than the window chance? If it is, I set it to 0. If it is not, I set it to 1. And then I put that, I set all that in an array. Why 0 to 1? Well, that is the first instance, is the 0 instance. That is the 1 instance, which is why if I grab this guy and I start dropping my window chance, the windows are going to be randomly replaced. So window shape is going to be randomly replaced with blank shape. So I'm forcing the instances to obey these IDs. I'm essentially building an instance ID array inside of here to get this to do what I want. It was the first idea I had. It's not the best idea. It doesn't give you very much control. It's very random, and it's very, very based on what order your array's in, and you need to know what that is and be. It's magic numbers, basically. I know it's 0 and 1. You don't. Nobody else looking into this would know what that is until they went back and checked the array. It's a dumb way to do it, but it's a fast way to do it. So at this point, if I took the output of these walls and just plugged it straight into the out array, you see, everything is that wall, and everything will obey that window chance. Except for the corners, which are a different thing. So you see what's going on there. You get blanks or you get windows. A little bit of weirdness going on the top floor, but we'll get into that later. So let's plug our actual array back in. So that's our window choice, random window choice array. That's what that's made. I take that array and I'm doing something really similar again. So I'm taking the number of floors, taking 1 away from that, and then I'm taking the point floor number. I'm saying, are you equal to this? So if you're equal to the number of floors minus 1, you are the top floor. You're this. Finds all true in that statement, uses those indices to set in the array a value of 4. 0, 1, 2, 3, 4. Roof shape. It's this thing. This little half shape here. So you can see how this is going, right? And how this quite possibly is not the very best way to do this, and it's okay because I'm changing it. We got our top floor. We do something similar for the ground floor, right? We go, okay, so get point floor number. Are you equal to 0? Yes. If you're true, if that's true, then all of those points with that setting, point floor number of 0, are the ground floor. And the first thing we do in the ground floor is we set everything to a value of 2, because 2 is this index here, this show window thing. So if I was to just plug that in, we're going to lose our doors, and everything's going to be this instance. Great. Then we need to go and do some doors. So again, we're doing a check. We're going, okay, look, if you've got a building with, I don't know, 32 sides, and you go up to your settings here and you put in like, well, I want 60 doors. Well, you can't have 60 doors in a building with 32 sides, right? So all this is doing is it's going, hey, if this is greater or equal to the maximum number of points, which is the point size here, then take 1 off it and make it that number. So you basically get everything is a door except one thing. Otherwise, just go with the number of doors. It's just a safety check. It's a limit. Moving on. So this is, we're doing a loop here for the number of doors. We're taking all of the ground floor points. So these are the points that are on the ground floor. and we, for some reason, we're taking the size of those points, the door seed, and inside of here we're just looping through one at a time. We're adding the door seed to the current index, making a random value between 0 and the size of the door array, which is, this guy, and then pulling a random number from that array and outputting it. What that does is allows us to set the door instance, which just happens to be instance 3 in this case, to that random value. And we're almost done. Basically, what we don't have right at this point is we have this. We have our points, we have all of our orientation sorted out, but we have nothing on our corners. Just undo that. So, finally we get to the mysterious green box. The mysterious green box is pretty simply, if we just get up here, we'll turn off the geometry for a minute. The mysterious green box is a corner detection system. If I do that, that's every single outside point. We've used this array before. Every single outside point. It's the beginning and end of each of these outside strands. That's cool. What this one is every single corner. And you can see here how that works. That's a corner, that's a corner. The point that's here, this point here is not a corner. It is straight. This is not a corner, it is straight. How did I do that? Well, inside my fine corners, I had to do some stuff. First thing I had to do was bring in my strand position array. All my outside center points are the blue ones. Strand position array is the point position of, and we can follow it all down here, the strand edges. So it's these guys. It's the beginning and end of each one of these strands. I had to bring those in. I had to flatten out the strand position array like this. And this, as you can see, became, it's 44 arrays. This is now an array with 88 points in it. And then I had to go through each one and remove every duplicate point. And the way I do that is I find each one in the whole array and then find how many times it matches and then take the first one, basically. First in array there. So this is just removing all the non-matchings. This takes the first one. That way I just get one value for each one. It's a real quick and dirty hack, but it works. And then I build an array of positions from my original array, which is my strand position array. Here, construct points out of that. I do a get point radius here, where what I'm doing, the geometry I've got coming in is the purple ones. The positions I've got coming in are these ones. So I'm basically adding these two together to make an array here. That's what build array is doing. So I have an array with all of the points in it. Then I'm going through finding everything in a radius of 1 with a maximum number of 3. Getting all of those from the array. Because what this is going to give me is essentially every single purple point and the 2 closest blue points to it. And then inside there I am getting those 3 points, making 2 vectors from the point to the first neighbor, point to the second neighbor, doing the dot product. If the dot product is -1 or is less than 0, if the dot product is not less than 0, then it's a corner. I'm not going to explain dot products or cross products today. Plenty of resources for you to go and look up. But essentially it allows me to see the angle between this vector and that vector, or that vector and that vector. Cool. The upshot of everything is that I can get the corner points. And once I've got the corner points, leave that on. That's pretty good. But I am going to turn off that because it's starting to get just a little confusing in there. So I have the corner points being shown and I have the outside center points. We'll just go to the corner points for now. Once I've got the corner points, I can run the same loop on it and basically instance my pillars on every single corner point going up that loop for the number of floors. The only thing I want to do is I don't want the top floor. So instead of doing it this way with instance IDs, I did a mask weights. And what that does is it takes the point floor number again, and if that's equal to the output, it finds all that is true in an array. In the meantime, it makes a new array with size 1, which means a weight of 1 means it will instance. And then everything that it finds that is equal to this value, which is number of floors that isn't less than or equal to 0. So this is just the number of floors you enter in, going up through here. And if it's saying, hey, if you're equal to that, then hey, you're the top floor. So it takes all the top floors and then sets it to be 0 in that weights array. Plug that into the weights. A weight of 0 means it won't instance. Plug it on out and you've got pillars. And that, my friends and esteemed community members and anybody else that happened to be listening, is how this is done. We're done. We've instanced everything. This is literally an office block generator that works by instancing. Now, that was a quick overview. I realize I've been talking for about 40 minutes at this point. This is a quick overview. I didn't show you how I did everything, and I didn't explain the tools. But this, coupled with the file, should be enough for you to get it going for yourself. You'll know where to find me. If you don't, you're watching this on YouTube, you could leave me a comment. I'll pick it up. It might take a little while. But yeah, I hope this helps. Have fun with it. I'm still working on it. I'll be releasing something better soon. And at that point in time, I'll look at doing a full tutorial series. All right? Hope it helped. Thanks a lot and have a good night.